Hello everyone, so today's question is called populating next right pointer in each node. So sorry, given a binary tree, populate each next pointer to point to its next right node. If there is no right node, the next pointer should be set to null. Initially, all next pointers are set to null. Okay, so with this given diagram, it's very clear what we have to do. Basically, we have to connect this 2 with 3 and this 3 finally with null. This 1 with null, and then over here 4 with 5, then 5 with 7, and then null. Okay, so we can see that this is kind of like we are going level by level. So we can use a queue data structure for this. What we'll do is basically first initially we'll add one and null pointer to queue. I'll explain it by writing. For example, if my queue initially has one and null pointer, okay, now what will happen is I'll say, okay, now if I have one, so the queue front is 1, right? So like whatever is the queue front, so it's 1. Now push back, so basically push back 2 and 3, that is child of 1, that is right child and left child of 1 in the queue. So I'll say, okay, I'll add 2 and 3 in the queue and remove 1 from the queue. Now 1 will point to the next queue front, which is null pointer in this case. So I can say that queue next is now null pointer. Okay, now we can give some case like if the next time we'll do the same. So next time we are getting null pointer, so we'll simply say, okay, if we are getting null pointer, we can't uh, do anything with this, so we'll simply pop it and then we'll add null pointer to its back, and then we'll continue repeating this. So the intuition behind this approach is that we can see it's a level by level traversal, and usually when it comes to level by level traversal in trees, we think of level order traversal, and then we think, okay, how can we use queue over here? So yeah, now I think we should start coding, because that's how I can explain it better. So okay, whenever if root is there, then only we can do anything. So that is the basic condition, and I'll say that we'll first make a queue data structure with node star queue. Now as I said, we'll first manually just push the first root node which we have. So I'll push root, and then we'll push queue dot push null pointer. All right, now that we have two elements in our queue, I can start traversing queue. So I'll say, okay, till the queue is not empty, till my queue is full, I'll travel through it. So while queue is not empty, so not queue dot empty, while queue is not empty, I'll be doing this condition. So first we'll take the size of queue, int n equals to queue dot size, because we have to loop through all elements of the queue. So it will be for int I equals to 0, I is less than n, I plus plus. Now as I said that now we'll take the first element of the queue. Let's just call it temp. So temp equals to queue dot front. Okay, now I'll check. Okay, we have to pop it as well. Okay, now as we have stored it in temp, we can pop it. So now I'll check if the first thing we should check is if t is equal to null pointer. If it's null pointer, we can simply just push null pointer to the queue. Okay, so q dot push null pointer, because it states that okay, it's the end of first level. Now that level has ended, so we can push null pointer, and once it does, yeah, then we can simply write continue, because once this is satisfied, we don't need to do anything, so we can continue it. Now if it's not null pointer, else I will say, okay, sorry, so if it's not null pointer, then it will be some number, and then I can say that okay, simply write t temp next will be equal to q dot front. Okay, now we need to push the child elements of this temp. Why am I writing t all over? Okay, so I'll check that if temp has a left child, then simply q dot push temp left, right? And similarly, if the queue has a right child, so if temp has a right child, we'll say q dot push temp right. Okay, now there will be one more condition, that is if queue size is 0 at any given point, and if t is null pointer, then we can simply return the root, because it means that the queue is empty and we have traveled it completely. So just to save some time, I can say that if q dot size is equal to 0, that is it's empty, and t is equal to null pointer, that is we are at the end of the root, I can simply say that return root. Okay, so now finally, once we are done with all this, we can simply return the root, right? Okay, so this will be the solution. Now let's try to run it. I think there's something wrong with this. Okay, yeah, so this was the solution. I hope it was well explained. Thank you.